what we've been talking about in the last couple days is something like if I have x squared, come on, marker, there we go, x squared, let's go plus 6x plus 8 equals 0. We know how we can solve that, right? We factor that by looking at two numbers that multiply to give us 8, but add to give us 6, right? What are those two numbers? Okay, 4 and 2. So x plus 2, x plus 4 equals 0. And because we got two numbers being multiplied together to give me 0, that means we take this one, x plus 2, set it equal to 0. We take x plus 4, set it equal to 0, and then solve. Okay? And we get those two in. Those are the two solutions that make this statement true. When I plug in on the left-hand side, all that stuff goes to 0, and I get 0 equals 0. That's the technique we've been using. What we learned today, the quadratic formula, is an alternative way to do that. Okay? Some people prefer it. Sometimes you have to use it. So we saw an example the other day, like if I change this to like x squared plus 6x plus 19. In that situation, there are no numbers that multiply together to give me 19 and have to give me 6. So in that situation, when you cannot use the other techniques, you have to use the quadratic formula. The quadratic formula, I like to refer to it as the catch-all. Okay, I mean it's my safety net. If I don't know how to factor something, I plug it into this and it will factor for me. That makes sense? Okay. You can use this 100% of the time, or you can use it when you see fit. Okay. Maya, do you have a question?
I forget how to tell, like, if you should put subtraction or addition in this, like, you know what I mean?
So I've been in class, so when I was a student, like my teacher would try, like there are rules that if that's a minus or if that's a plus or a minus, what has to go in these two. I always think about, if this is a positive number, if that 8 is positive, then these both have to be both positive or both negative. That makes sense because of how a product works with positive numbers and negative numbers. If this is a negative number, okay, then one of these is positive and one of them is negative. But then you have to look at what this number is here to decide which one is positive and which one's negative. All right, so key concept here. It says formulas are shortcuts for procedures that are repetitive. Okay? So there are logical and mathematical principles that allow the formulas to exist. What I want you guys to understand is that this formula down here we see in the middle, halfway down, says x equals opposite b plus or minus all that garbage. That is a formula that is not just somebody haphazardly took a bunch of letters and symbols and picked them out of a hat and said, yep, it works. Okay? Or that they defined it that way, they made it that way. It doesn't work that way. Math doesn't work that way. Okay? There are relationships, that repetitive processes that we've seen that we do that says, okay, let's do this repetitive process using generic values. Instead of using numbers, let's use A, B, and C, which are our coefficients of our quadratic equation. Let's do this repetitive process on those and see what we get. And when we do that, we get that thing right there. Okay? I'm not going to show you how it becomes true. Okay? It's called the derivation or the creation of that formula, but I want you to know that it's a creation. It's not an invention. It's not something that we made and said it works. And does that kind of make sense? Okay, we may discover, and that's another word. Okay, so this formula is created from a procedure. Yeah, from a procedure called completing the square, which we're not going to do. Maybe you've heard that before in Algebra 1. I'm not going to waste your time right now with completing the square. Okay. All right, so this is your quadratic formula. Okay. It's called the quadratic formula because it attaches to a quadratic equation. Okay, this is our fundamental basic quadratic equation, right? Okay, now the A, B, and C we've been working on in the last several weeks of being able to identify those and use those, right? We use the A and the B inside finding the vertex and all that kind of stuff. So here, we're going to use the a, b, and c inside this formula. Okay? It says any quadratic of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers. A cannot be 0. The reason a can't be 0, if a was 0, that thing would right there would disappear, and you would just have a linear equation, which is really easy to solve. Okay? But every single quadratic equation can be solved using this formula. Okay? The only thing that happens inside this formula that people struggle with is the order of operations. Okay? So this formula will allow you to factor any quadratic equation that we have already factored using previous methods, and also any quadratic equation that previous methods could not factor. Okay? Something to keep in mind, okay, we'll talk about something called the discriminant. This thing right here is the discriminant. Okay, if you ever hear me say that. It basically allows me to determine how many solutions we're going to have for this problem. How many times basically we cross the x-axis. Okay? How many times the parabola cross the x-axis. It says b squared minus 4ac. It says this quantity will tell you how many solutions your quadratic will have. This is basically saying if that number is positive, or greater than 0, you're going to have 2 real solutions. So there will be 2 places on your x-axis that your parabola crosses. So if the discriminant is positive, your graph will look something like this, where you cross 2 times. Okay? Or it might be concave down, so you might be able to flip that curve, but it's going to cross 2 times. Okay? If this discriminant is equal to 0, okay, if the b squared and the 4ac cancel each other out, what you're going to get is your graph just to touch your x-axis 1 time. And when it touches your x-axis just 1 time, it touches that vertex. Okay, so that's some nice relationships there. Okay? And the last one says if my discriminant is negative, okay, and this is the reason, okay, square roots. If I take the square root, and you guys remember doing square roots, right? Think about 2 numbers that multiply together to give me like 16. 4 and 4, right? Okay. 2 numbers that multiply together to give me 17. 4.123, 4.123. Okay. 2 numbers that multiply together give me like -9. It says undefined. You can't do that. You cannot think of 2 numbers that multiply together to give you a negative, because a negative times a negative gives you what? A positive. And a positive times a positive gives you a positive. So 2 numbers multiplied together by themselves, there's always going to be positive. So you can't take the square root of a negative. And that's what this is essentially saying here, is that when this square root is a negative, you will not have any real solutions. Your graph will look something like that, or maybe like that. It will not cross the x-axis. Does that make sense to everybody? Okay. Now, initially, those 3 conditions, we're not going to spend a whole lot of time just saying, okay, what's the discriminant, how many solutions I'm going to have. We're actually going to work through and find what the solutions are, but that quantity might help us maybe guarantee or confirm our results. Okay? This process, guys, do it by hand a couple times, do it using technology a couple times, and like I said, the hardest part is really the b squared minus 4ac part. Okay, people mess those orders of operations up. But the more we practice this, the better you'll get at it. First thing we're gonna do, first thing we'll do is take our, and don't worry about this saying completing the square examples. We're not gonna do that. We're just gonna start doing quadratic formula here. So I want to identify what a, b, and c are. Okay, so what is a in this case? Okay. 2x squared is the term that comes from it's just the 2, right? So a is just 2. B is 2 as well. And c now is -12. One of the biggest issues is when we plug into our formula, when our A, B, or C's are negative, people struggle with those. Okay, so just be careful. In addition, number one error, people will say C is just 12. They'll forget to take the negative with it. Okay, so you got to make sure that you do that. Our formula is X equals the opposite of B plus or minus B squared minus 4 times AC all over 2A. Okay, before we start plugging things in, we'll talk about that plus or minus. The plus or minus there basically tells us that there's going to be 2 amps. I don't know if we've ever seen this before. But if I have something like, if I say 3 plus or minus 5, I'm really giving you 2 amounts right there. Neither of them being 3 or 5. I'm giving you the amount 8, because 3 plus 5, right? And I'm giving you the amount negative 2, because 3 minus 5. So that's what's going on right there. There's 2 solutions that are going to be generated when we do this, okay? And it's the reason it exists is because in creating this formula, they took square roots. And if I take a square root of like 16, okay, so I introduced a square root. Are there 2 numbers that I could have multiplied together to give me 16? 4 and 4, right? But does negative 4 and negative 4 also work? Okay, so there's a positive 4 and a negative 4, so that's a positive negative that generates right there. That's why that's there. Okay. Now that we've got the formula, all we got to do is plug things in. So this is going back to what we did like week 2 and substituting. X is always going to be X. Okay. This minus sign is always going to be a minus sign. So it's going to be minus 2 right now. Then we got plus or minus. Got your square root. Things inside the square root, I always, when I substitute, always like to put parentheses around them. So the B, I'm going to put parentheses around it, and then I'll square it. Minus 4. The A is 2, and the C is negative 12. All over then 2 times the A of 2. Kind of highlight things here. Kind of give you an idea of where those terms came from. Opposite B plus or minus B squared minus 4AC over 2A. Now, order of operations tells us that we need to look inside parentheses first. And what happens with square roots is square roots are actually a grouping symbol. Meaning that this square root, this discriminant, needs to be done first. Okay, so I want to look at this as maybe, I want to use black, I want to use white. So maybe I want to do this like, I want to figure out that amount first. Does that make sense to everybody? Okay, so if I find that amount first, what do I have to do in there first? Say it again? Okay, parentheses and exponent. So I think maybe it makes sense to go ahead and do the 2 squared. Can we change the 2 squared to 4? So remember the square root here. Now I've got 4. Okay, now we can do this multiplication. Okay, so this is what I always do. I always do that power 2, and then I will multiply these 3 numbers. So what's negative 4 times 2? Negative 8. And then I'll take negative 8 and multiply it by negative 12. So negative 8 times a negative 12. What's negative times a negative? Positive. Okay. And then 8 times 12 is 96. So everything else stays, it's still a -2 plus or minus outside. Can I do this multiplication on the bottom? 2 times 2? Change that to 4. Okay, so now we're going to just try to evaluate this. I got -2 plus or minus. What does this turn into? What's 4 plus 96? 100. All over 4 then. Okay, and we can keep simplifying. What's the square root of 100? 10. So we got -2 plus or minus 10 over 4. So what that means then, so once I get this down, and not all of these will the radical completely disappear. Sometimes it stays. It just depends on what that 100 number is, what that discriminant is. If it's a perfect square, the radical will disappear. If I get down to this, now I get negative, what this is saying is -2 plus 10 divided by 4, and it's saying -2 minus 10 divided by 4. So what I like to do is write both of those separate. So I go -2 plus 10 divided by 4, and then I'll write the other one, -2 minus 10 divided by 4. And back to order of operations, we talked about how that division bar acts as a grouping symbol as well. And it basically tells us you have to do the top first. What's -2 plus 10? 8. Then put it over 4. And that will reduce or change to 2, right? Down here on the bottom, -2 minus 10, -12, divide that by 4, you get -3. And when you get down to that far, that is what x is equal to. X is equal to 2, and x is equal to -3. Those are your two solutions. Those are two spots that this graph would cross the x-axis. Does that kind of make sense? Okay. Now, some people might say, oh, that was a lot longer, a lot more messier than factoring, which I could agree with maybe in some situations. But in other situations, this is the only route that you could go. All right. Let's see here. Let's go 2x squared. We'll start with the original problem, plus 2x minus 12 equals 0. If I would have started with the original problem, and I said, we're not going to use the quadratic formula, or you don't have to use the quadratic formula, some of you might have said, oh, everything up there is divisible by 2. Would you agree with that? Can I divide everything by 2 up there? So if I divide everything by 2, I get x squared plus x minus 6, right? Can anybody think of two numbers that multiply to get me -6 and add to give me 1? -2 and +3, good. And if those are equal to 0, solve this, x minus 2 equals 0, x plus 3 equals 0. Does that give me x to be 2 and x to be -3? Are those the same exact answers we got using the quadratic formula? So doing it that way, the only reason I do it that way is to justify or to confirm to you that we are doing something that works. It does get the right answer. Sometimes I would argue that this was less work. This was, to me, now I've been doing this for 20, 25 years. To me, that's a little bit easier. Okay, and I can see right off the bat that that's going to work maybe faster than the quadratic formula. But at the same time, I also know the quadratic formula will never fail me. The quadratic formula will always work. Does that make sense? Okay. I don't want you to rely on this 100% of the time, because there will be situations where this fails us, okay? Especially when we get answers that are not exact answers, and we'll talk about that a little bit tomorrow, but we could do this. We could say, I could type in opposite of B plus, now I don't have a plus or minus here, so in a minute we'll have to change this But then I can hit square root b squared minus 4ac, put a parenthesis, division, put 2a on the bottom. Okay. Now I can hit a, I want it to be 2, b, I wanted it to be 2, and c, I wanted it to be negative 12. And it will take those values, it'll take those three values, and it will plug it in here for you, and it'll get you your answer. One of our answers was 2, right? Now, because I don't have a plus or minus, I would then need, if I'm going to use this, I would then need to come back to this, delete that plus sign out, make it a minus sign, and get my second answer of negative 3. Is that doable? Okay. Again, you can use this, but do not rely on it, because what happens when that is a 1 or a negative 1 instead of a negative 12, that number we are going to want written a different way than this, and the calculator won't do that, okay? So the calculator I only want you to use, or it's only going to be a benefit to you when that number right there terminates, or is what we refer to as rational, okay? So it ends in like 0.0 or 0.5 or 0.25, something like that. 0.3 repeating will be fine. Does that make sense? Tomorrow we'll pick up with doing the rest of those examples on there, but that's the nuts and bolts of the quadratic formula. I will open, it'll be in a couple, probably about an hour or so, I will open up a Math Excel assignment over this. And I'll make it due today's Tuesday. I'll make it due Friday, because there's some more examples I want to go through before it's graded for you. So be on the lookout for that. That's all I've got for you.